I'm here today to talk to you about From Summaries to Insights, 1 year of AI engineering. And I was here pretty much a year ago to the day talking about the first iteration that we at Pendo have been working with LLMs and how we've been using it to summarize content. So a little about me. So I work at Pendo for the past 2 years. I should say 2 years. I recycled this slide from last year. I've been focusing on AI work. Before that, I worked at a digital creative agency in Sheffield, and I studied computer science at the University of Sheffield. So here's the slide from last year. So it was my AI journey, lessons in experimentation and challenging AI maximalism. And the presentation today is really a continuation of that. As a quick overview of what we do at Pendo, so when most people hear Pendo and you live in the US, because it's a well-known brand over there, not so much in the UK at the moment, we're working on that, but it's a product analytics platform. And the part that we work on in Sheffield is actually user feedback. So if you're ever on a website and you see on the right-hand side of the page, submit feedback, that's pretty much what we do. So it gives insights into user behavior, and it lets companies who use it use reasoning to back up their investments in their software. So on the analytics side, we ingest about 25 billion events a day. So this is things like click events, page navigations, and whatnot on websites. So that's a lot of data. That adds up to over 7 trillion a year. Our GCP hosting bill is quite large, as you can imagine. This is an example of what we do in Sheffield. So as I said, we work on feedback. So this is a very small example of a feedback request that you probably can't see. So it's got a title. I've blanked out some user information. You've got the description. So typically, you go to that right-hand page on the website, you click submit feedback. That text there is the feedback that you give. If you're on Amazon, you might say the checkout process sucks. Why is it, 2, 3, 4 steps, yada, yada. So large customers, they can have more than tens of thousands of those kind of feedback requests. That kind of text quickly adds up. So, on average, when I did this calculation a year ago, I think it was something like, across those 10,000, if we took an average number of characters, it adds up to over 3 million characters, which is 638,297 words. Quick facts, there are only 550,000 words in the entire trilogy of Lord of the Rings. So, the person who is typically looking at this feedback, they're a product manager. I know what the calendar for my product manager looks like. I know that he has nowhere near enough time to sit through and read Lord of the Rings, the entire trilogy. So when AI and LLMs came about, we really thought about how can we solve this problem. And what we landed on was feedback summaries. Here is a screenshot of how it was a year ago, I believe. So essentially, we take all that feedback, we pass it to an LLM, and we ask it to summarize it. Obviously, it's a bit more complex than that. We do some special things in terms of getting it to give topics. So in this section of 8,000 feedback requests, apparently the 2 main topics are usability and user experience, and additional functionality and integrations. It's not very granular, probably because of something we were doing with the prompts, but overall, we give it some feedback and it gives back a summary. And that was great. We got lots of really positive feedback about it. So when we first demoed it, these are the kind of responses we were getting. Straight up perfect, accurate summary. I love that it breaks it down into simple to understand themes. And it was really gratifying to hear, hearing that we're actually doing a good job. But what I actually found even more interesting was when we got this response back. So this customer, they came up with a term that they phrase the Goldilocks syndrome. And essentially they're saying that if there's too little feedback, it's just parroting back the feedback that's been given. It's not actually analysing it. It's not generating any overarching themes. And if there's too much feedback, Well, it doesn't drill in enough. And also, how are you ever going to actually validate what it says? You know, going back to that previous example, 7,981 feedback requests, I think. How can you know that anything the LLM has written actually drills down into any singular one request? And, you know, a year ago, you couldn't. So that really prompted the last year of work that we've been doing. You know, how can we prove that what the LLM has written, how can we prove that the summary is correct? And further, how can we enable the PMs, the people who have to sit and sift through, you know, this mountain of text, how can they take action on the summary? That's really talking about, you know, that drilling in, citations, so to speak. And at the end of my talk last year, I pretty much spoke about this and I gave what I thought would be an approach to solve it. And one of the big issues that we had at the time was stable topics. So because we pass it to an LLM, it means that every time we query it again, there is the chance, however slight, you know, we have a small temperature set on the request, it could give back something entirely different. This is really confusing, and the citations I've already spoken about. So at the end of the talk last year, I gave an approach, what I thought that we'd be doing in the next year, this year, to fix that. And step one was clustering the data. So I spoke about stable clusters and the lack thereof of LLMs. This was, you know, trying to solve that. So we take all the feedback requests and we generate what is called an embedding. If you're in an AI talk, I'm willing to bet that most of you have actually probably heard of embeddings before. They're a vector representation of a word that encodes the semantic meaning. So for example, the word king might have one number, the word queen would have another number. If you think about the words king and queen, they're very similar. They're to do with the same topics. That means that when you plot those numbers on a graph, they're going to be close to each other. Here's an example of that. So I've plotted a few words in vector space. So we've got PC, cat, kitty, volcano, bank, money, car and truck. You can see that the ones that have had their embeddings generated, the ones that are similar, they're close together. So car and truck, bank and money, cat and kitty, volcano and PC, both kind of outliers. So this is about creating those topics and making sure they're stable. So they're going to be the same no matter how many times you ask the LLM to generate it. The next step, you pass those topics to the LLM, get them to name them. The previous step, you know, it doesn't have a name for them, it doesn't have a description, but what you can do is you can pass the group that you've clustered, you know, car, truck. Hey, ChatGPT, name this cluster for me, give me a description. And then finally, once you've got that, you can do the summaries, and then we're back to the slide I showed you originally. And once you've got that, I don't think at that point it would be too difficult to do the citation generation. So that's kind of the idea that I outlined last year. How far did my plan actually go? Was it right? It was so-so, you know. There's a lot that is very, very different. And so, you know, jump straight in. Part one is what I'm calling insights. So once we got those feedback summaries and we started getting responses talking about things like the Goldilocks syndrome, or, you know, that critical feedback that we desperately wanted, we went back to the drawing board. I remember sitting through and going through tons and tons and tons of feedback requests and looking at, you know, the shape of the data, how they differ and whatnot. And here's an example of one. So you'll notice here that this is one feedback request. This is one piece of text, but it's got 1, 2, 3, 4 different points in it. And each of those points, you know, they're quite different. If I was to cluster this, I don't know realistically where it would go. If I were to split it out into 4 separate parts, if I clustered them and there was a similar feedback request that was unique and granular and was related to this point 4, then logically you'd expect those to be clustered together. If we, you know, created an embedding from this entire piece of text and then tried to cluster it, the results weren't great. So the feedback that talked about many different unrelated points were heavily, heavily impacted by this. And you saw how many feedback requests a large customer can have. None of that data is uniform. It causes havoc when you're trying to do any analysis like this. So we basically settled on, we want to be able to extract the different parts from the feedback request and cluster those individual parts, not the feedback request on a whole. And the name that we kind of settled on then was Insights. So I didn't have a good example of this as I put it together about half an hour ago. But essentially, we would pass this to an LLM and we'd say, pull out different insights from this feedback request. The critical part, though, is that at the start, we were pretty much just getting the exact same text back. We didn't get it to do any transformations on it. And what we would do is we'd store, the different insights that it gave back. So 1, 2, 3, 4. We'd store them, in the database underneath that piece of feedback. And, once we've done that, we generated their embeddings and we're away at the races. Just to circle back on the embeddings, because when I was doing this, I realized might need a little bit more of an explanation. I use the example king, woman. So because they're numbers, you can do math with them, semantic similarity. So if you take king, add woman, and then you minus man, these are the embeddings that you get thrown back. So you get queen, which is the kind of result you probably expect if you're talking about semantic analysis of text. You've got throne, you've got prince, daughter, Elizabeth, all words that are very much related to, that kind of strange addition, subtraction of words that you're doing at the top. So we've got the insights, we've plucked out the different parts of the feedback requests that we care about. What next? Normalization. So we took these insights we plucked out of the feedback and I started trying to cluster them. But the results actually weren't all that good. We looked at the groupings of the embeddings in vector space, and it didn't really make much sense. It was sometimes telling us that insights that were completely unrelated by human eyes were actually closely grouped together. And the other thing that we really struggled with was, noisy data. If somebody went and face mashed against a keyboard, it was just a random string of text, that would actually have a high similarity to, normal pieces of text, which is not really all that good. Really, what gives there? And, when we looked at that, we started thinking there's two things that we're probably missing here. The first thing was hybrid search. So I've spoken about embeddings and I've spoken about semantic search. Obviously, before that became all the craze. Everyone was using things like Elasticsearch and doing keyword search, or they're doing, tag searches. Our feedback requests, they've got loads of labels, they've got loads of tags, they've got loads of metadata. We should be leveraging that alongside the embeddings, alongside the semantic search to get improved results. And then secondly, the variance in the feedback was massive and it was causing issues. If you think about all the different ways that you could say the same thing in the English language, then you throw in, incorrect spellings or regional dialects or however they type or industry-specific terms, and you can start to see why we were getting the bad results that we were getting. And at that point, something really quite big happened in the Pendo world. We acquired this AI startup in New York, and they were working on, a very similar project to us, almost the exact same project, honestly. There we go. Yes. So they were an AI-first feedback platform that was built from the ground up to have those AI capabilities. Where they differed from what we were doing is they really only focus on the AI. We had all of the old functionality that you would expect from a feedback tool that has been around the block for a few years. But with them, they brought a lot of really cool like AI concepts that we jumped on board with. And the first one that we saw when we were integrating the two products was they have something called a uniform format. So I've just spoken about the variance in user supplied text. If you read these two things, you should see that they're pretty much saying the exact same thing. If there was a feedback request and it had different points and we pulled these out, and then we did semantic search against them. If semantic search works as you would hope, then it would have a high semantic similarity. That's not always the case. It struggles when things are, like wildly varying different text lengths. What the uniform format does is instead of just, naively plucking that text out of the feedback request and creating an insight out of that, it actually does a transformation step with the LLM. It gives the LLM some constraints. It says, reword this insight, keep it within 2 sentences, don't go over 100 characters. And what it does is it creates the data in a uniform format, hence the name. And once you've got that uniform format, it means that the embeddings, that semantic similarity search you're going to be doing is going to be so much more effective because you're at a level playing field. And the key point there, cycling back to the citations issue that I'd mentioned, is when we generate those insights, when we ask it to generate that uniform format, we save the text that we pass the LLM as a reference. This means that the output text that we get from the LLM, we can reference it back to the original feedback request. This means that we can show, if somebody looks at an LLM summary and they're like, oh, it's saying we want an integration with Gong, you can actually follow that back to the original feedback request with the user information of the person who submitted it, and you can see exactly what they're saying, and you can see how the AI inferred the topic that they generated. There we go. So at this point, we've got the embeddings, we've got functional semantic similarity search that actually works as we want it to. The next step, step 0, step 1 on the thing I showed at the start, is clustering, so grouping together those uniform format data points. And yeah, disclaimer, this is going to be a very, very high overview. There is not enough time in a single talk probably to talk about everything that is going on. If you want to talk about it, I will take a drink of Guinness. So coming back to this representation of embeddings in vector space, again, if we were clustering this, you'd expect car, truck, bank, money, cat, kitty, and then volcano and PC as the outliers. That is essentially what clustering is. You're plotting data points in vector space and finding ones that are close together. You would have some threshold of similarity. So because they're numbers, you can work out the distance between two things. You can say, oh, the distance between car and bank is greater than, 3 or whatever distance you want to say. That means they're not similar enough to create a cluster, so don't. So yeah, this is just a very quick overview of how you do clustering. Step 1, apply filters. You might not want the entire data set. There's really no point processing unnecessary data. Step 2 is dimensionality reduction. Again, like I said, very high overview, but embeddings, they're long numbers, long vectors. They're normally about, well, the one that we use has 768 dimensions. That's to say that it's 768 floating point numbers. And working with those high dimensionality embeddings is difficult. It's costly in terms of processing and storage. So what you actually do when you're trying to work with stuff like this is you actually reduce the dimensionality on it. So what you do is you put all your points together, and really all you care about is the relation of one point to another point. So you reduce the dimensions down while trying to maintain that relation. The specific algorithms that we use are UMAP and TSNE. If you want to chat about that afterwards, please, by all means. And then once you've got that, it's just that grouping. So what I was doing, by hand with the laser pointer, There's loads of different algorithms for this, k-means, db-scan, hdb-scan. We use both of the latter at Pendo for what we're doing. Easy, right? So to bring it back to what we had a year ago, this is a summary. These would be the topics: usability and user experience, additional functionality and integrations. And I'm very, cognizant at this point that I've just been speaking to you for probably about 22 minutes about some very kind of technical details. So what I can actually share with you today is a new version of this that's hot off the press. I think it's actually one of the first demos that we've done live for any of this. Brilliant, here we are. So this is what the application looks like as it is today. So first thing is we've got a list of topics. These lists of topics are generated from the highlights. The highlights are generated from feedback items. So the feedback items are the raw data that the customer provides. So this is all like demo data. So what here we want a Gong integration, or we're cancelling contract, Zendesk integration, and we've got 1,415 of these. So what we've done is we've taken these feedback requests, we've put them through our insight extraction. If you worked in a large organisation, you'll know that renames are a very common thing. So since we started using the term insight, the product people decided to rename it highlights, hence why it's highlights in the UI. So we run the feedback items through our highlight extraction system, and it generates these. So the Gong integration request would come out to something like this. And this actually relates back to that first feedback item that we saw in the list. So this is all LLM generated. This is the exact text from the feedback request. And we've got 1,889 of them. So as you'd expect, that's from requests that have more than one singular point. And then at the next level up, we've got the topics, which is the clustering of the highlights. So you can see down here, we've got the list of topics. So the most requested thing from this feedback is a DocuSign integration. The next one is a Slack integration, and then the next one is a Gong integration. I think if you're a PM, you probably empathize with that, because the most feedback you probably get is like, I want a Jira integration or whatnot. So you can click into the topic, you can see the high-level overview. So customers are expecting a need for integrating DocuSign with Acme CRM. Underneath, you can then see the highlights. And again, you can click through the highlights to the base feedback, the raw feedback that the customer submitted. Awesome. So that's the demo. Sweet. So to go back to what I theorized would get us to a solution last year, we've got clustering, theme generation, summary generation, and citation generation. I thought it would be fun to actually see what we actually have. So the big difference comes at the start of the process. It's the normalization and the insight generation step. That's all about generating that uniform format and then using that to get the insights, and then linking that insight back critically to a specific piece of text in the feedback. The clustering part, that's fairly similar. I think that was number 3 in the previous one or something. So I think I was fairly spot on with that. And then, naming the clusters as well, which is just passing that to an LLM and saying, give me a name and a description. If I think about the key takeaways of the past year's work, not involving the year prior, it really comes down to probably 3 or 4 things. Number 1 is the data normalization. That's the uniform format. I really can't stress how important it is in the process. Without that step, none of the further steps really would have been that valuable. Unless you're, it comes back to the more traditional ML and data science approaches. Unless you've got high, good quality data, your solution, the output that you're getting is probably going to be shit. LLMs, what they offer is, normalizing that data on a large data set as it comes in without having to pay a data scientist, vast sums of money to do it by hand. Instead, you pay those vast sums to OpenAI. Number two, if I'm being honest, the hardest part of all the work that we've probably done in the past year has been navigating the security and the legal concerns. So at Pendo, we have customers in EU, we have the US, we have Japan. All of them have, different legal requirements in terms of data storage, but then also, data privacy and what LLMs you're actually allowed to use. That was an absolute headache, doing different routes through the back-end code depending on region, locality and whatnot. That, really was quite annoying. A lot harder, a lot more annoying than actually doing the data sciencey, LLM, AI programming, engineering part. And then three, this is something that I was thinking about today because it really is quite scary, and it kind of links back into what James was saying in his talk. From my point of view, LLMs, they just keep getting better and better and better and better. The kind of tasks that we threw it 2 years ago when we asked it to do the summaries, it couldn't handle citations, it couldn't link things back to the underlying text. Now, not only does it do it, it does it faster and it does it cheaper. And that's in the space of 2 years. I've seen the comparisons with the new O3 models that OpenAI have put out, and while they are, losing money, $200 a month, and they're still losing money, at the rate of improvement that I've seen in the market, I wouldn't be surprised if they're not losing money anytime soon. So, for people like me, that's pretty scary, but is what it is. And I think that brings it back home. So this is a shout-out slide, I think, from previous year's presentation that I forgot to update. But people on my team, JC, Drew, Steve, Mark. Cheers.